Lesson then to calculate the circumference and area of a circle using the diameter and radius, and to solve problems involving the circumference or area of a circle. Let's check our prior knowledge before we start then. You should know the names of the parts of a circle. There is a recap coming up if you're not sure. Be able to substitute into a formula, be able to round answers to decimal places, and to know where the pi, square root and square buttons are on your calculator. So if you're using the normal Casio calculator, then your pi button is this little yellow one here above the x10x button, which is down here at the bottom of your calculator. To get that, you will need to press the shift button at the top and then the x10x to get the yellow pi. And your square button, here we have x squared, and our square root buttons are just here underneath this big blue central button, or if you've got the slightly newer style calculator, there are 4 grey buttons here instead, but it's right on this very first full row of buttons. If you've got a different calculator, just make sure you know where those buttons are on your calculator. They may be in different places and they may look slightly different. Okay, things you need to complete this lesson then. You need your maths book and some paper to write on, a pen or a pencil to write with, and you'll need a scientific calculator that has, as we've said, pi, square root and squared buttons on it. Okay, so a quick recap on circles before we start then. So a circle is a set of points equidistant, so that means of equal distance from its centre. So we've got our centre here, and our circle is made up of lots and lots and lots of tiny points, all the same distance away from the centre, which then creates this line. Now the distance around the outside of the circle is called the circumference. The radius is from the centre of the circle to the edge of the circle in any direction. And the diameter is the distance across the circle passing through the centre. Now that's very important. It's only called the diameter if it passes through the centre. If it goes through somewhere else, we call it a chord, and we'll come on to those later. So we want to make sure our diameter must pass through that centre. Make sure you're happy with those descriptions. We're going to be using these words circumference, diameter and radius a lot during this lesson, and we need to make sure we know the difference between our radius and our diameter quite clearly. Okay, so we're going to start by finding the circumference of a circle. So the circumference is the perimeter of the circle. It's around the outside, and we can't really measure it with a ruler because it's a curve and not straight lines. So we need another way of finding that circumference. So by using a formula, it makes it a bit easier. So our formula is C, capital C for circumference, is equal to pi d, pi times diameter. And we can see our diameter then from one side to the other passing through the centre of the circle. So in words, circumference equals pi times diameter. And our pi symbol here, if we don't have a pi symbol on our calculator, we can use 3.142 as an approximation of pi. All right, let's have a look then at how we use that formula to find the circumference of a circle. So if we're given the diameter of a circle, we first start by stating the formula. It's important we write down the formulas because this tells us what we're trying to find and what we need to be able to find it. So we need pi, well that's programmed into our calculator, and we need the diameter, and we can see on our diagram they've told us the diameter is 14. So all we need to do is substitute the value of d into the formula. Now remember, pi next to d means pi times by d. So with algebra, when things are next to each other, they are multiplied. So we're going to do c equals pi times 14. If we put that into our calculator, we get 43.9822 and some other numbers. Now remember, pi is an irrational number, goes on forever and ever and ever. We don't want to write down our calculator display forever, so we write down at least 4 decimal places, and that means if we are then going to round our number later or use it for other calculations, we're not going to get rounding errors. So at least 4 decimal places. I use the dots here just to remind me that I know that this number does continue, and I may keep that longer number stored in my calculator if I'm going to use it later. Now we can round it to an appropriate degree of accuracy. I've rounded to 1 decimal place this time. which comes to 44.0, and our unit there should be meters. Okay, so 44.0 meters it should read, because our units here are in meters and it's a length, so our single unit of meters. Okay, so our key point then so far is that if we have the diameter, we multiply the diameter by pi, or 3.142 if we don't have a pi button, to get the circumference. And do a couple more examples just to make sure we're happy. So here we've got two different circles. The first one, we've got a diameter of 12. So again, we start by stating the formula. We need to substitute the diameter d for the number 12. So we get pi times 12. And we put that in our calculator, 37.6991 to 4 decimal places at least. And then we'll round it to 1 decimal place. We get 37.7 centimeters. Now, occasionally you'll be asked to leave these values in terms of pi. And all that means is that we don't actually complete this calculation here. So if I wanted this in terms of pi, instead of writing pi times 12, for algebra we don't write time signs and our numbers come before our letters, so we would put 12 pi. So if it does ask you to give the answer in terms of pi, it simply means give the number multiplied by pi, but without putting it into your calculator to get a decimal. Okay, our next one then, state the formula. Substitute d for 9 this time. Pi times 9 is 28.2743, etc. And rounding to 1 decimal place gives us 28.3, and this one is in meters. Make sure you're happy with those and you've copied down the examples before you move on. Okay, so now it's your turn. You've been given the diameters of 3 different circles. It asks you to find the circumference. Give your answer to 1 decimal place. Pause the video, have a go now. Okay, so the first one then, our formula, circumference equals pi times diameter. We're substituting d for 2, so pi times 2, which is 6.2831, etc. And rounded to 1 decimal place, we get 6.3 meters. For the second one, again, we've stated our formula. We're substituting d this time for 4, so we get pi times 4, which is 12.5663, etc. And rounding to 1 decimal place is 12.6 meters. And finally, our formula, we're substituting d this time for 7. So pi times 7 is 21.9911, etc. And rounded to 1 decimal place is 22.0 meters. Again, just to remember, it has asked for 1 decimal place. So even though our 1 decimal place value is a 0, it is important we put that in. Otherwise, we will round to our whole number and not to 1 decimal place. All right, so we're going to have a look now at how we find the circumference if they give us the radius of the circle. Now at the beginning we remind ourselves the radius is from the center to the edge, the diameter is the whole way across. So our formula says we want circumference equals pi times diameter, but I haven't been given the diameter, I've only been given the radius. So my first step is to find the diameter. Now the diameter is all the way across, so we've got halfway. We need the same again, so that's 2 lots of the radius. So 2 times 9 means it's 18 meters across. So we need to use that 18 in our formula. So the circumference equals pi times 18, which is 56.5486, and other numbers that we're not writing down. And again, rounding to 1 decimal place again this time, 56.5 meters. So if we're given the radius, we need to double it because our formula says we want the diameter instead. Again, let's do a couple more of those. So your key point there, if you have the radius, multiply it by 2 first to get the diameter and multiply that by pi. So our first one then, we're told the radius is 10. Our formula says we want pi times diameter, so we need to do pi times 22 lots of the radius. That comes to 62.8318, etc. To 1 decimal place, 62.8 meters. Our second one then, again, we need diameter. We've been given a radius of 8. So 2 times 8 is 16. So we're going to do pi times 16. That gives us 50.2654, etc. And rounded, that gives me 50.3. And this one was in centimetres. Make sure you're happy with those. It'd be a good idea to copy down those examples before you move on. Okay, so again, you've got 3 there. You need to find the circumference, give your answer to 1 decimal place. Bear in mind you've been given the radius this time. Pause the video, have a go now. All right, so our solutions for these then. So our first one, again, stating the formula every time because that's telling me what I need. I need the diameter, radius of 2, so the diameter will be 4. So that's pi times 4 is 12.5663, etc. and rounded to 1 decimal place, 12.6 meters. Our second one, the diameter is going to be 10. So pi times 10 is 31.4159, etc., which is 31.4 meters. And finally, our last one, the diameter of that one, 3 times 2 is 6. So pi times 6 is 18.8495, etc. Rounded to 1 decimal place gives us 18.8 meters. Okay, make sure you've got those units at the end. We need to know it is a measure of length. All right, so now we're going to move on to some problem solving then. So it's all very well being able to find the distance around the outside of a circle, but why do we need to know it? Well, let's have a look at this first one together. So Katie makes cakes for special events. She uses a cake tin with a 20 centimetre diameter. She puts a ribbon around each cake and she allows an extra 2 centimetres of ribbon for joining. How much ribbon does she need for each cake? For part A, and then part B, we've got she buys the ribbon in rolls of 25 meters. How many cakes can she decorate for 1 roll? So she's going to put this ribbon round the outside of her cake to make it look a bit nicer, but bearing in mind she wants an extra 2 centimeters so the ribbon can be joined together at either end. So as it's going around the outside of the cake, that means we need to know the cake's circumference, and we're told its diameter is 20. So we start off then with our formula, and our diameter this time is 20, so pi times 20 was 62.8318, or 62.83 centimeters to 2 decimal places. It's up to you how much you round it. You might continue to use all 4 decimal places for the moment, or you might want to round it before then. Now that's just the circumference. We need the circumference plus 2 centimeters because of the overlap. If we add on 2, we get 64.83 centimeters of ribbon for each of the cakes. It says now then she buys the ribbon in rolls of 25 meters. How many cakes can she decorate from 1 roll? Well, the first thing to notice is that that's 25 meters, and we know our length as 64.83 centimeters. So as with all maths, we need our units to be the same before we continue. So we're going to change our 25 meters into centimeters, 100 centimeters per meter, so times by 100, and we get 2,500 centimeters. Now we want to share that 2,500 centimeters between lengths of 64.83, so that's a division. If we divide that, we get 38.56, and again I've rounded to 2 decimal places there. Now we can't decorate 38.56 cakes. That would be 38 whole cakes and just over halfway round another cake. So we want to obviously know how many whole cakes she can decorate, because no one's going to decorate half a cake. So we would need to round down this time. So she has enough for 38 full cakes, and she will have this 0.56 left over that she won't be using. All right, so now it's your turn then. So a similar sort of idea. Peter is putting edging around a circular flower bed with a diameter of 460 centimeters. The edging comes in 245 centimeter sections. How many sections of edging does he need to buy? Pause the video and have a go at that one now. All right, let's have a look at this then. So we're going around the outside of a circular flower bed. So we're going to need to know the circumference. We were told the diameter is 460 centimeters. So let's find our circumference then. C equals pi d. We know d is 460. So pi times 460 is 1445.1326, etc. And I've rounded that again to 2 decimal places. Again, you could use the 4 decimal place number at this point if you wanted. So the edging comes in 245 centimetre sections. So we'll check our units first. We have centimetres and centimetres, so that's perfect. So we want to share our length of our flower bed around the outside of our flower bed into groups of 245. So we're going to divide again. Now that gives me 5.9 edging strips to 1 decimal place. But again, I have to think logically. I can't go in the shop and ask for 5.9 lengths of edging. I would have to, in this case, round up and buy 6 lengths of edging. All right, so if I need to go into the shop to buy it, if I only bought 5, I wouldn't have enough. It wouldn't get around the last 0.9 of the circle. So that's nearly another whole way around a circle. I'd get nearly there and have a gap. So I have to buy 6 sections of edging, so we'll end up with a little bit left over at the end. So be careful with these types of questions, whether you have to round down or whether you have to round up. All right, we're going to move on now then to finding the area of a circle. So the area of a circle is the space inside the 2-dimensional shapes. So again, other shapes, you might put them onto square paper and be able to count the squares on the inside to find the area, but we can't do that with a circle. You can see we get lots of little bits of squares rather than whole ones. So we need a more accurate method. So again, there is a formula we can use. The formula for the area of a circle is area, capital A for area, is equal to pi r squared. R standing for the radius. So remember, the radius is the distance from the centre to the edge of the circle in any direction. And this time we're squaring it. So we're doing pi times the radius squared, or pi times r times r. So if you don't have a squared button on your calculator, you will need to do pi times r again. So remembering squared means something multiplied by itself, not multiplied by 2. All right, let's have a go with this formula. So again, we state the formula first. To find the area, I need to do pi multiplied by the radius squared, and they have told me the radius is 3, so I substitute the value of r, and we get pi times 3 squared. Now, if you have your calculator with your squared button, then that's great. You can just type this in. If you don't, you might want to work out 3 squared first. So 3 squared is 9. And again, if they asked me to leave this answer in terms of pi, I would now simply say a equals 9 pi. I would get rid of the times symbol and just put the 9 in front of the pi. So if you are asked for it in terms of pi, that means at this point you don't carry on, you just rewrite it as proper algebra. We do want to have a decimal answer for the moment though, so we're now going to put that in our calculator. So you can either type in pi times 3 and use the squared button, or pi times 9. We get 28.2743, etc. Again, because we're using pi, we will always get this really, really long number that we don't necessarily want to write it all down. And now we can round it. So we get 28.3 meters squared. So we're talking area, so we're talking square units. So our formula here has a squared and our answer has a squared. Okay, so a good way to remember is that we've got a squared in the formula and we have a squared for the units of the answer. Let's have a look at a couple more as well then. So our key point there, if you have the radius, square the radius, then multiply by pi. All right, so 2 more examples then. Start with our formula. That's not the formula. Okay, sorry, another one of my many typing errors. That should say A equals pi r squared. We're finding the area. So we're going to substitute in our value. So we know that r is 10 So we're going to put in pi times 10 squared. We can just directly type that into your scientific calculator. As I said, if you don't have a scientific calculator, do 10 squared first, or 10 times 10 instead. If we put that in, we get 314.1592, etc. And rounding that to one decimal place, we get 314.2 meters squared. Our second one then, so we've been told again the radius is 8, so start with the formula. We're going to swap in r for 8, so pi times 8 squared, which comes to 201.0619, etc. And that to one decimal place is 201.1 centimeters squared this time. So again, making sure we've got the square units as appropriate to the question at the end of each answer. Okay, make sure you've got these examples then, and we'll move on to having a go yourself. All right, so there you are, 3 more for you to do then. So pause the video, have a go at finding the area when you're given the radius. All right, so the solutions for these then. So again, state the formula. Pi times 8 squared first of all, which is 201.0619, or 201.1 centimeters squared to one decimal place. The next one, we're going to substitute r for 12 this time, so pi times 12 squared, which comes to 452.3893, or 452.4 centimeters squared to one decimal place. And finally, area is pi r squared again, so pi times 4 squared, we get 50.2654, etc., or 50.3 centimeters squared to one decimal place. Check your answers, make sure you're happy with those before you move on. Okay. All right, so this time then, we're going to see if we can find the area, but we've been given the diameter. So again, we start by stating the formula. Area equals pi r squared. Now, we've been given d, the diameter. Our formula requires r, so we need to find r. So remember, r is halfway across the circle. We know the whole way, so we need to divide the diameter by 2 to find the radius. 10 divided by 2 is 5 centimeters. So we're going to substitute r into our formula. We get pi times 5 squared. Again, 5 squared is 25, so if you don't have your scientific calculator, work that bit out first. And that comes to 78.5398, which rounds to 78.5 to one decimal place, or 54 centimeters squared to two decimal places. All right, we'll do another couple of examples just to check then. So our key point there was, if you have the diameter, half the diameter to get the radius, then square it and multiply by pi. All right, so our first one then, we've been given a diameter of 9. We need the radius for our formula there. Half of 9 is 4.5. So we're going to do pi times 4.5 squared, which comes to 63.6172. And to one decimal place is 63.6 centimeters squared. Our second one then, again, our formula says we need the radius. Half of 12.8 is 6.4. So pi times 6.4 squared is 128.6796. And round that to one decimal place, 128.7 centimeters squared. Make sure you've got these examples then before you move on to have a go for yourselves. Okay, so 3 more for you to do this time. So this time you've been given the diameter, but we are still going to find the area. Pause the video, have a go now. Okay, let's have a look at the solutions for this one then. So our formula, we are going to do pi times 6 squared because we've got a diameter of 12, the radius therefore is 6, which is 113.0973, etc., or 113.1 centimeters squared to 1 decimal place. For our second one then, our diameter is 4, so our radius must be 2. So we're going to do pi times 2 squared, which is 12.5663, and that's 12.6 meters squared to 1 decimal place. And finally, again, 15 centimeters, we need the radius, which is 7.5. So pi times 7.5 squared is 176.7145, or 176.7 centimeters squared. Make sure you're happy with all of those and that you've got those units at the end as square units to show that we're finding area. All right, let's try a bit of problem solving with this one then. So for this one, you can either pause the video and have a go yourself, or you can continue and work through it with me. So we're asked to calculate the area of the concrete surround of the circular swimming pool. So we've got a rectangle made of concrete and we've got our swimming pool in the middle of it. So to do this, we need to start by finding the area of the rectangle. The area of a rectangle is the length times the width. So we'll do 4.7 times 8.2 is 38.54 meters squared. Now remember, that's all the concrete completely filled in over the top of the pool. We're now going to find then the area of the pool in the middle. So our formula for area of a circle, pi times r squared. Now we need to find the radius. We've been given the diameter. Half of 3.8 is 1.9. So we get pi times 1.9 squared, which is 11.3411, etc. Or we can round that 11.34 meters squared. So I've now got the area of the concrete filled in and I've got the area of the pool. So we need to cut out the pool from the concrete so that we just have the grey bit left. So we need to subtract those. So we're going to do 38.54, which is our rectangle, our concrete, subtract the pool, which was 11.34 meters squared, which gives us 27.2 meters squared for the concrete surround. It now says then Rachel covers the concrete with non-slip paint, and each tin of paint covers 8.5 meters squared. How many tins does she have to buy? So again, our first check, the area that we want to paint is in meters squared. Our tins of paint come in meters squared, so our units are the same, so that's great. So we need to share out our 27.2 meters squared with 8.5 meter square tins. So we're going to divide them. If we divide them, we get 3.2. Now again, I need to think about my answer. I can't walk into a shop and ask for 3.2 tins of paint. I either have to buy 3 or I have to buy 4. If I bought 3, I would have 0.2 of my concrete left without any paint on it, so I'd have a gap. So I'm going to have to round up again and buy 4 tins, which means I'll have a little bit of paint left over, but that's okay. It's better than not having enough. Okay, so finally then, we're going to have a look at, if we're told the area, can we work backwards to find either the radius or the diameter? So we're going to start by working backwards to find the radius. So again, we start as always with our formula, but this time we know the area A. So we're going to substitute A for 26. So we've substituted in our value and I've put my time sign back in between my pi and r squared. Now remember, we're trying to find r, so we need to get rid of pi from here. I want to keep r by itself. To get rid of pi, it's been multiplied, so the inverse of multiplying is dividing. So we're going to divide both sides by pi, and that will make r squared the subject now. So if I divide this side by pi, the pi's cancel, I get r squared, and I've got 26 divided by pi on this side. Our next step then is we need to get rid of the squared from here because we just want r. So to do that, we need to do the inverse of squaring, which is taking the square root. If I square root r squared, we just get r. And I have to square root everything that's on the other side. That's really important that I put my square root over everything that was on the other side. Now I can type this into my calculator. So we know hopefully where our square root button is. You can use your fraction button if you've got one on your Casio calculator. If you don't have one, remember this is 26 divided by pi. So you could do square root brackets 26 divided by pi, close the bracket. Make sure you use the brackets so that it will do that division first for you. That comes to 2.8768, etc. So at least 4 decimal places as always with these. And then we can round it appropriately. So I've rounded it to 1 decimal place. So the radius is 2.9 centimeters. Okay, make sure you've copied down all of those steps before you move on. Okay, so this time then we're still given the area, but we're asked for the diameter. So we're going to work our way through again. So again, we start with our formula. We know this time the area is 48, so we substitute in our values. Again, we want to get r to start with. We need to find the radius first. Once we find the radius, then we can find the diameter. So we're going to divide by pi, so divide both sides by pi. That gives me 48 divided by pi is equal to r squared. To get rid of the squared, we're going to take the square root of both sides. So we get the square root of 48 divided by pi, and we put that into our calculator. That gives me 3.9088, etc. Now I know the radius, but I want the diameter. Remember, the radius was from the center to the edge. The diameter is from one side to the other going through the center. So the diameter is 2 lots of the radius. So I'm going to multiply that by 2. And you can see here, I've put that same number with the dots, because that means I've kept whatever this long number was in my calculator and just then press times by 2 so that I don't get any rounding errors. So you can see now I've written a few more digits down just to show you that I used the whole number that was in my calculator rather than my rounded number. And I get 7.817642. Again, the numbers would continue from there. If I round it to an appropriate degree of accuracy, I get 7.8 centimeters for the diameter. Again, make sure you're happy with those, you've got all those notes before you move on to have a go yourself. Okay, so there are 2 questions there for you to do then. You need to work out the radius and the diameter of the 2 circles. Pause the video, use your notes to guide you, and have a go now. Okay, so the first one then. So to find the radius, again we start with our formula. We substitute for a. We're going to divide by pi. Then we square root to get us the radius. The radius 6.3002 or 6.3 to 1 decimal place. The diameter, 2 lots of the radius. So we've multiplied our calculator by 2 and we get 12.6 to 1 decimal place. For B then, again, start by finding the radius. So start with the formula, substitute the area, divide by pi, square root. That will give us a radius of 2.0958, etc. Rounded to 2.1 centimeters. The diameter, we're going to multiply our calculator display by 2 and rounded again to 1 decimal place gives us 4.2 centimeters. All right, well done for working through that one today then. Next lesson, we're going to have a look at sectors and semicircles.